Okay, tonight's homework, section 7-1, worksheet 1. Are we ready for problem 1?
Yeah. No.
Okay, without graphing, determine whether the function represents exponential growth or exponential decay, and then define the y-intercept. So, the very first thing you're going to say, is it growth or decay? That is determined by looking at the value with the exponent. It is 1/3. Is 1/3 a fraction between 0 and 1, or is it a whole number greater than 1?
Fraction.
It is a fraction, so therefore, is it growth or decay? It is decay, and my growth decay is 1/3. What is my y-intercept? My y-intercept is going to be the value a attached to it, so that's going to be 0, 0,0.99. That is my y-intercept. Do we understand the first few problems there? One more time, let's do number 2. Is this growth or is this decay? Why is it growth? Because this is greater than 1, and 1.75 is my growth factor. What is my y-intercept? 0,20. Any questions over the first 4? Moving right along, number 5. There is A and B, I believe. Is there A, B, and C?
Yes. A and B.
Just A and B. Okay. So, is this letter A? Suppose you deposit $1,500 in a savings account that pays interest at an annual rate of 6%. What does the 6% mean?
It's growth.
0.06, and it is growth, so A of t is equal to my A value, which is 1,500, times 1 plus 0.06 raised to the t. Now, part A says, how much will be in the account after 5 years? So you're going to type into Desmos 1,500 parentheses 1.06 raised to the 5th power. And what does that give you? $2,007.34. He was dead on. So that is going to be $2,007.34. Make sure you understand that you're talking about money, so you need the cents afterwards. Do we all understand that? Okay, number 6. Okay, a population of 1,236,000 grows 1.3% per year for 10 years. So, how many people are going to be living in this area if my population grows 1.3% yearly? Is this a growth or a decay? It's growth. So this right here, the 1.3% is going to turn into what decimal? Point 0.013. 0.013. You are going to move this to the left 2 units, okay? So I'm going to have A of t is equal to, what is my initial population? 1 plus 0.013, and I want to know how many years? 10 years. So in Desmos, you're going to type 1,236,000 times 1.013 raised to the 10th power. How many people live in this region? Nobody wants to do that for me?
1,406,413.
How about 1,406,000 413 people? Yes? 1,406,413 people. Okay, number 8. The directions on number 8 say, for each annual rate of change, find the corresponding growth or decay factor. I need your brain to understand that that right there actually means 1 plus or minus r. Do we understand that? Now for number 8, it says plus 45%. So what does that mean?
0.45%.
You are having 1 plus 0.45. So that is going to be 1.45 growth. Yes? Do we see that? What does number 9 mean if it's minus 10%?
Okay.
That's going to be decay, so we're going to have 1 minus, put this over 2 decimals, so 1 minus 0.10 to give me 0.90 as your decay. Yes? Does that make sense? Are we good? Okay, are we ready for this one? Now, do I have any hunters in here? I need you to understand that this example right here is how we get the number of tags that you are able to use during deer season in specific counties. This is a problem compared with bears, but if you would just simply change it to being deer, you can get the whole concept of how that could work out. So are we ready? In 2009, there were 1,570 bears in a wildlife refuge. In 2010, how many years difference is that?
1.
So in 1 year, the population had increased approximately 1,884 bears. So it went from 1,570 to 1,884. Do we understand that? If this trend continues and the bear population is increasing exponentially means that you have this. You with me? That's that formula. How many bears will there be in 2018? Okay, I'm telling you, I know this year compares with that number, and this year compares to this number. And I know that the time difference between those 2 years is how many years?
1.
1 year. So I'm going to have my balance in my refuge, which is 1884. That has to equal to my initial amount times the growth rate of 1 year difference. Do you see that? I need to know what this is. That is the growth factor that I'm then able to make a trend line to do future predictions. Does that make sense? So how do I solve this? Do I need to have this 1 right here? That 1 is unnecessary to be there, so I can simply erase it. So how do I solve for what I've highlighted of 1 plus r there? How do I get rid of that 1570? It's attached by multiplication, so the opposite of multiplication is division. So we're going to take and divide both sides by 1570. So what is 1884 divided by 1570? 1.2 is equal to 1 plus r. What does 1 plus r represent?
1 plus 0.2.
What is it? The growth factor. So 1.2 is my growth factor for this region and this refuge for my bears. Does that make sense? So whenever I go to plug it into my formula over here, this 1 plus r I already know, don't I? I know that to be 1570 is what I started off with. I know this is 1.2. Now I want to know how many bears I'm going to have when I started in 2009 to when I end in 2018. How many years is that between them? 9 years. So how many bears will I have?
8,100.
I will have 8,100 bears in 2018 based upon a 1.2 growth factor.
So I take it you don't want decimal when you're counting whole thing.
I don't want a decimal on there because can I have a point of a bear?
Yeah.
I can't have half of a bear. Pregnant bears do not
You want
count.
us to round up the decimals still?
Nope.
Or no?
Nope. Okay, because we can't count up yet. Do we understand that, yes or no? Okay? If you're talking about a fish pond, if you're talking about a deer population, anything like that, if you're talking about populations for people, all of this is the same exact concept. Do we understand this, yes or no? Great. Last problem. The price of a new home is $350,000. The value of the home appreciates 2% each year. What does that mean? It increases. Appreciate means it's going up in price. Depreciate means it's going down. why would a house appreciate in value?
Have you seen the market?
Why? Tell me.
Because more people need homes, and when you're trying to move to nicer locations, it's harder to do because there's a lot more people and a lot less homes.
Where do families mostly try to move into?
Big city.
Not necessarily.
Suburbs.
What is a parent's most number one important thing about their child?
Safety.
Safety and a good school system. So if you have a good school system, people are going to move into that school system and want in that district, so the appreciation value for every one of those homes in those districts are going to rise very, very, very high, exponentially. Does that make sense? If you have families moving out of a school system, what is going to happen to all the properties within that region?
They'll go down in value, they decrease.
They will either stay constant or they will decrease with value. Okay? They will depreciate. Okay? They will not get that. If you have a lot of families move out of a district, or you don't have new families being born into a district, all you have are older couples, you are not going to have a very successful school system within that area. Does that make sense? So appreciation versus depreciation is very, very important. So if we go to this concept here, we talk about this, A of t is equal to A parenthesis 1 plus or minus r to the t. Appreciate means we're growing, so my initial value is 35,000. I am growing at a 2%. What is 2% going to be? 0.02. And I want to know how much money I'm going to have and how much my house is going to be worth after 10 years. And what is that going to give me? A 10 up there. So what are you typing into Desmos? Is this right here. And how much money is my house worth?
$426,648.05.
600 and what?
48.
And 5 cents. Yes, I want my cents, and you need to make sure that you give them to me. Uncle Sam takes them, so you need to make sure you give them to me as well, yes? Any questions over tonight's assignment? Do you see the relevance in it and how important it is to understand this stuff? Okay, you guys are on your own.